Okay, so hi, my name is Ray Cromwell, and I'm CTO of a company called Timefire. And this presentation's sort of if you saw my presentation earlier in jQuery, this is sort of a little bit higher level and more of an ad hoc presentation about how to use GWT and many of the other Google APIs to sort of build, or at least try to build a product. So this is really about my personal experience over like the last year of trying to build an application and sort of the steps that I took and how I was able to leverage Google's offerings to sort of fill in holes in what I was trying to do and sort of increase my productivity. So this presentation should have been called There's an API for That instead of Building with Google APIs, because it seems there's about 7 presentations called Building with Something. The one before that in this room was also called Building with Something. But really, if you look at what's going on with Google, they're releasing a tsunami of APIs. If you just go to code.google.com, you'll see about 60 APIs alone, and those are just sort of the publicly documented ones. If you go to like code.google.com/p and search for sort of projects that Googlers work on, there's far more than that. And they cover the full spectrum of needs for an application developer. You have client-side frameworks, server-side frameworks, you have cloud services, you have mobile, you have social, you have commerce. Basically, if you have a need, there's probably an API for it. And that leads me to sort of pose the question, does Google have a platform? Because if you look at it, it's starting to get that way. People have been sort of joking for years that Google should do a web operating system, and I think they're dangerously close to that right now. Maybe Wave will be that. So here's what I see as sort of the application ecosystem that Google offers right now. So I've sort of divided things up into several blocks, and on the upper left-hand side, you have client technology. So you can write client-side code in JavaScript. You can do it in Android. You can do it with Flash, actually. Like, for example, Google Maps API has a Flash client API. GWT, of course. What was just released recently, the O3D browser plugin. And actually, a lot of people don't really realize that icon in the upper left corner is Google Earth, but Google Earth includes a full HTML5 WebKit browser in it. So you can actually author complete applications and run them and host them inside of Google Earth itself. So then we move on over to the server. And typically when people do server applications, they have their choice of PHP, Java, Python, Ruby, everything in the LAMP framework that people are used to. However, now with App Engine, sort of a curious thing happens. You can run all of these on Google's own servers today. So in a sense, Google is sort of providing hosting services for all of these languages, whether they have officially announced it or not. Another crucial thing is, how do you communicate between a client and server? So if you're building a rich client like Flash or Android or GWT, you typically have to communicate between a client and server and ship data back and forth. There's a number of different ways to do that. Probably people's favorite way of doing it is with REST and JSON or some kind of XML format like Atom. Or there's an API called protocol buffers, which you can use, which Google actually uses for all of their internal stuff, which is very compact and has high performance. And for GWT, if you're using GWT on the client side, you have the option of GWT RPC. And I'll talk about maybe how you can choose which one of those will fit your application best a little bit later. And then, all the rage now is open social. And well, not open social, but social networking. So Google has quite a number of different ways to build social applications. You can use open social. You can use Google Friend Connect. And you can actually use the GData Context API to basically sort of have a pseudo-friends network using like your Gmail contacts. That's not quite as well known. They provide a lot of utility services, which you see reused over and over again. Like in the Wave demo today, you saw translation. Google provides translation service. You have Maps and Geo, of course. Visualization for charting. Search, authentication, like through Google User Service on App Engine. And then there's app services. So, for example, if you want to store spreadsheet data or other kinds of documents, you can use Google Apps. and there's GData APIs for all of those, so you can integrate them into your application. Finally, if you want to monetize your application you just built, down in the right-hand corner you have AdSense and Google Checkout. And I'd be remiss if I didn't mention the fact that you can choose to write applications today that transparently can move back and forth between Google's App Engine data store and MySQL, and I'll talk about that a little bit later. So let me talk a little bit about my application just as a way to sort of demonstrate what I've been trying to build and how I was able to sort of consume these APIs. So basically, I started off with trying to build an application that was like Google Maps, but for time. The idea there was basically Google Maps handles the spatial dimensions really well. You can fly over vast data sets. You can drop markers on them. People can collaborate. But there was nothing out there that sort of allowed people to search for vast amounts of time series data and fly over, just like you would do in Google Maps, drop annotations on it, and share your own insights about that data. So I started to try to build an application like that. So the first thing I did was I looked at client technologies. And one of the things I did was I originally wrote a charting API using pure JavaScript by hand. So the first thing I did was, this was before GWT 1.3, I said, all right, well, let me go use JavaScript. So I wrote a charting API in JavaScript, and to tell you the truth, it kind of sucked. Not because of JavaScript's fault per se, but there was a lot of things I wanted to do with the charting API that it was just hard to do with JavaScript. Like I wanted to run it on the server to generate thumbnails. I wanted to run it in mobile devices. And I just couldn't do that with the library written and hand-coded in JavaScript. So the first step was I got exposed to GWT, and I was like, wow, I could write code in Java. And maybe, besides just compiling it to JavaScript, maybe I could actually run it in a servlet and generate thumbnails. And maybe I could run it on J2ME devices. This was before Android. So this is an example of the charting library I built. And one of the core features I needed was performance. I was very, very concerned about performance because looking at Google Maps, I was thinking, people could load up time series data sets that were huge, tens of thousands, hundreds of thousands, millions of data points potentially. And I wanted people to just be able to smoothly fly over that data in real time without any kind of hiccups in their browser. And GWT was able to help me deliver that kind of performance in their browser. So for example, this is an example of a data set. It's got 22,000 data points in it. So I can zoom in over this in real time. You see how fast it updates. It's 80 frames per second. It's actually faster than most games you'll get on your Xbox or PlayStation 3 in terms of their update rate. It allowed me to do stuff like real-time streaming using Comet, streaming data in, synthetic data set overlays, like let me add a moving average to this. That's another example. But one of the cool things I wanted to do is I wanted people to be able to tell stories about the data. So, be able to drop a marker on the data and say, hey, look at this, something important here. Like maybe this point right here in this data set, which I think is unemployment, maybe it represents something important. So, maybe I should, add a marker there like this so that my friends can see it. I got clipped a little bit. But you can also, I could do something like add an axis marker. Let's try this. You can put one down there, and that could represent like a split in a stock or something. And you click it, and a little pop-up pops up, just like in Maps. So this was like the genesis of the idea. And I don't want to talk about this too much because I'm not really here to plug that. I want to sort of describe my experience in trying to build this thing. So I got this far, and I was like, well, what can I do next? Right? Because this is just a chart, big deal. There's lots of charting libraries out there. So I needed to take it to the next level. And one of the ways I did that was by looking at how I could make it more social. So I started looking at open social and stuff like Google Friend Connect. And I went and I built a widget that embeds this whole thing in an open social container. So what I'm going to show you is a demo of something called, that I call Time Lord. And this is that charting application, but hosted in an open social container. And I'm not showing it live because actually I broke something this morning in my code, so it actually didn't work for sure. But I'm showing you a screencast of this. And what this is basically you can drop this chart in an open social container, and people can annotate the data, make comments on it, just like a YouTube video, and it will actually post those comments to the person's activity stream to their friends. So, for example, you see up there on the top left it says, Al Gore left a comment on CO2 Epica ice core with modern. So he left some kind of comment on a chart about CO2 data. So I'm going to click that and move forward a little bit. And you can see, lo and behold, there's a chart here with 800,000 years of CO2 data, going back really far. And on the right-hand side, you see like a little YouTube-like interface that says, like, please watch my mini presentation. So as I was building this and adding the features for people to drop markers and log things to Open Social, I thought, why not let the person tell a story while they're at it? It's not enough to just say drop a marker here and say there's something funny going here or there's like something interesting here. What if I could tell a story about like why I think this data is the way it is? So one of the APIs I looked at to do this was the YouTube Chromeless Player API. I don't know if anyone's used it, but this is an enormous productivity benefit because if I didn't have that, I'd have to actually build out a video hosting service myself, build my own Flash player, export APIs for it. It would be just a tremendous hurdle. I've actually was able to implement what you're about to see in one day. So what you're going to see is a clip from Al Gore's movie, An Inconvenient Truth. And on the right-hand side, the video is going to play, and Al Gore is going to walk across the stage, and he's going to point out various things about the data you're seeing. And on the left-hand side, the chart is going to react to what he's saying, and it's going to basically add things. So I'm going to move it up a little bit so we don't have to watch too much of the movie and maybe get sued by the MPAA or something. But here at the top you see there's a subtitle. It says CO2 going back 800,000 years. Now he's going to talk about this chart and what parts of the chart are in different eras. So I could turn on the audio. I don't know if you can hear.
Anybody outside of a small group of scientists has seen this image. This is the present day era, and that's the last ice age. Then it goes up. We're going back in time now, 650,000 years. That's the period of warming between the last two ice ages. That's the second and third ice age back, fourth, fifth, sixth, and seventh ice age back. Now, an important point. In all of this time, 650,000 years, the CO2 level has never gone above 300 parts per million. Now, as I said, they can also measure temperature. Here's what the temperature
So now it's going to make an RPC call to the server and get a temperature data set and overload this. This is all being driven by text comments that are hidden behind this video in the actual comment. So there you go. It's compared with temperature. So I'm not going to let that go on too long. But the key issue is here is basically I created a system where people could write little wiki-like syntax comments in the commentary, just like you would do on YouTube. And you're able to reference things in the chart and drop markers, tell the chart to move somewhere, and to compare it with other data sets and all kinds of like funky stuff. And by using the YouTube Chromeless Player API, I was able to get bidirectional syncing between the chart and the video up in like one day. So if you move the chart around, the video actually can go to the certain time code to actually react to where that chart was supposed to be. You can sort of map the time code of the video to like the timeline on the chart itself. So without showing too much more of that, now I want to start talking about, if you guys thought that was interesting, how did I do that? But before I go forward, I want to show you another cool thing, because I think this is important when I get to talking about GWT. I built an Android version of this. Now, the interesting thing about this, if I can get it working, there we go, is that I didn't change any of the code in the web version. I was able to compile the web version that you just saw deployed in the open social container to a native Android app. It's not running in a web browser. It's a native app, Java bytecode or Dalvik VM code, and just have it run in here. So you'll be able to see it's doing some stuff now with OAuth, which I'll talk about a little bit later. But it's going to go get a token. I'm going to log in. Let me skip ahead. It's going to ask me to approve, give me an OAuth token. And there you see the same sort of chart data. It's dropped some markers on the chart. There's the ability to go look at those markers, what the comments were that people said. You can add a marker. You can share via a number of different networks. So in this example, it's going to share a comment via Open Social REST with Al Gore. And what happens is when someone clicks this and says, I want to share this comment that I just made on this chart, it uses the REST Open Social API to post it back to the container here. So now I'm going to go click on the inbox on my Partusa Open Social container, and you can see in the sent box that there's a message sent to Al Gore which says, come look at this chart. And I did that completely from the mobile device. So it's like the same functionality that's available in the Open Social container is also available on the mobile device. So hopefully that kind of gives you a taste of some of the cool stuff you can do. The question is like, how do you do it, and how do you do it without repeating code and running two clients and things like that? So that's what I'm going to try to explain, which is how to achieve what I would say is a lot of code reuse between various client technologies. So first thing you should know about Android, if you don't already, it's almost a full J2 SE Java stack. It has tight integration with the WebKit browser. You have a local database. You have 2D and 3D APIs. You have sort of an externalized way of representing widget layouts, which makes it really easy to separate presentation and logic. So how was this done, right? Even the Android client, how was it done? Well, GWT is the foundation. If I didn't have GWT, I wouldn't have been able to do this. So what happened is I write the app to the GWT APIs, which are a subset of the normal Java APIs. And if you target those and you stay within those APIs, it turns out that you can compile that code cleanly and run it on Android with very little changes. So, you could write a game that works in an open social container on a social network, and then you could make that same game run on the Android device and put it on the Android market. So I hope that's like a very compelling use case. Now, obviously, though, there are platform-specific things you have to do. So, you just can't target the, GWT emulation library when you need to draw stuff on Android or talk to native Android widgets or handle events. So this is where Juice comes in, Juice Dependency Injection. So hopefully some of you have attended those sessions at Google I/O on dependency injection and the Juice library. But I use this all over, and I've kind of fallen in love with it. And so basically what you do is this. You write as much code as you can, sort of cleanly packaged and only using the GWT JRE emulation library classes, and the 1.6 event system in GWT, which there's a package called shared, and if you stick to those interfaces, it can run in the server, on the client, anywhere. It's sort of abstracted away from the browser. And then what you do is for device-specific or platform-specific stuff that you need to do, like wire up event handlers or draw stuff to the screen, you use dependency injection to inject implementations of those particular bits of functionality. So like one of the things I do to draw the chart is I use the HTML5 canvas in the browser to do all the line drawing. But on Android, I actually don't use the HTML5 canvas. I use the native Android graphics libraries. So what I did is I just simply created an interface called Canvas that has many of the methods like line and set colors and fill this and that and translate and scale and rotate. And then I dependency inject different versions. So on GWT, I will dependency inject the one that's the HTML5 canvas, and on Android, I'll dependency inject the one that's the native Android implementation. So you do have to write some extra code on each platform, but it's very small. You maybe have to implement 1 or 2 classes to get it up and running. Very powerful. One tricky thing is wiring up event handlers. So, the event handling system on Android is completely different than the browser one. On, GWT, you have click handlers or click listeners. On Android, it's a completely different system. But what you can do is this. You can code all of your stuff to the GWT 1.6 event system that was just introduced. And they have interfaces like has click handler. And it has a method on it like add click handler, and it takes the callback function. It's going to be called when somebody clicks on that widget. And what you do is you inject the device-specific implementation of that interface. So you might, for Android, you might inject Android click handler, and for GWT, you might inject like a browser click handler. Essentially, on GWT, the Juice API is called Gin. So if you haven't heard of it, it's sort of under the radar. It's one of those APIs that's not on code.google.com. There is a dependency injection framework for GWT called Gin, which is actually just Juice, but implemented for Gin. So this is one way where you can write one set of logic for handling events and then sort of cleanly inject platform-specific event handlers if you need to. Like if you need to specifically handle something differently for the Android device versus the browser. Typically, it boils down to like network I/O. Like, you need to either inject a script tag on GWT to basically load up a REST call, or on Android, you have to use the HTTP client, things like that. So what's Juice? It's dependency injection like Spring, if you've used the Spring before, but without the XML cruft. So it's all done with annotations, and they use a lot of method chaining. So if you saw my GWT query or jQuery presentation earlier, it's sort of uses the method chaining technique to sort of make your code terse. It's very compact, but it's very powerful. And here's the thing. It now works as of Juice 2.0 inside of App Engine on Android and in GWT. That means you can write code that you could deploy to App Engine on the server, run it as JavaScript, or run it inside the mobile device. And so there are sometimes you want to write code that actually can run in all three places because it's very generic utility code. So as I said, Gin is basically Juice for GWT. It uses compile time generators to do AOP, dependent style method interception and stuff. Here's an example of what dependency injection looks like if you've never seen it. So like I could write a class called checkout, and maybe it has to take another class called order processor that knows how to process the order. And typically the way you would write this is you might have an order processor factory, and you might call create or get instance, and it would basically return the instance, the actual implementation of order processor. And there might be different versions of order processor depending on whether you're against checkout or whether you're against PayPal. Maybe for testing, you've got a mock order processor. But with Juice, what you do is you just write @inject on the constructor of this class. And that's it. You're done. And then basically there's a little config class you write later where you say, well, in this instance, I wanted to inject the PayPal order processor, and in this instance, I want it to be the Google Checkout order processor. So it allows you to sort of rip and replace functionality out of your code really easily without being too entangled on factories and other static dependencies. So this is a list of the APIs that I'm going to try to talk about or cover in some way. And these are the ones that I've kind of been prototyping and using with my application. OpenSocial, FriendConnect, GWT, Android, those are the tops. GViz, I'll show you a GViz integration in a second. Hopefully you find that a little bit cool. Maps, ringtones, and Spreadsheet, YouTube, check out. You saw the YouTube integration already. So first let's talk about social, right? So there's usually three things when you want to sort of integrate social into your application, right? You want to get a list of the friends of the current authorized user. You want to send messages to those people sometimes. And you want to post activities, like, somebody just did this on this app, like I attained level 10 in, Sudoku or something. So your friends can see it. And there's two current ways. I classify Google FriendConnect as like a subclass of open source. There's two current things that Google provides that allow you to write applications that leverage social, unless you want to use like Facebook or something. You can use OpenSocial and Google FriendConnect, and there's two different ways to do it. You can use the JavaScript APIs or the REST APIs. And then there's the Google Data Context API. And you can use that in some instances where you're not inside of an OpenSocial container. The question is like, how do you integrate OpenSocial with GWT and Android at the same time and limit the amount of code that you're duplicating between the two? So typically, what you might do is take the JavaScript APIs on GWT for OpenSocial and use overlay types or JSNI to wrap them. That's what a lot of people would do. And then for Android, you would probably use the REST APIs, and you would fetch JSON from the server using HTTP, just HTTP GETs. But then you might get tired of that because there's duplication. You've got to maintain these overlay type classes with all these JSON methods, and then you've got to maintain these REST classes, and they're sort of different. So you don't want to repeat yourself. So the other thing you can do is you could instead delegate the fetch logic on the server. So I could put all of the open social logic on the server that communicates with, like, say, MySpace and pulls your friends lists and logs activities. And then I could make the client simply ask the server to do it on their behalf. But then the problem is that how do you talk to the server using, like, Android and GWT and maybe Flash and other things like that? So obviously what we'd like is, like, option 3, which is, like, both on GWT and on Android. It's basically the same API. It's like ask the server to fetch it on your behalf via an RPC call. So I'll cover that in a second. Let me just digress for a moment. Like, the way I implement it is I create an interface called share provider and has 3 methods on it: get context, send message, and log activity. And then I use Juice to inject one of these 3 options here, which I've experimented with on each of the platforms. But obviously the best is to only inject one implementation, which is option 3, which is both of them delegate to the server and say, you know, give me my friends list. So I'll just skip that for a second. So how do you communicate with the client and server in sort of a cross-client agnostic way? We have 3 options. You can use REST with JSON or XML, which is what many people would do today and which many people would favor. Because it's kind of like the de facto standard. It's readable. You can look in Firebug and you can kind of see what's going back and forth over the wire. It's easy to debug. But there are reasons why you might not want to do it. You can use protocol buffers, which is what Google uses internally for almost all their stuff. So when you're doing searches or you're using, you know, Gchat or Spreadsheets or whatever, on the back end somewhere, there's like protocol buffers flying around Google's cluster. And then the other option is GWT RPC, which is built into GWT. So the question is like, which one of those 3 would you use? Well, let's look at REST, for example. You basically have to write code that serializes or deserializes your objects to JSON or XML. So if you're using GWT, like I am, and you've got a Java class, then you've got to make a utility class that can basically take a GWT object and generate JSON from it, or generate XML. The pros is that you can port this technique to any client, so if, you know, or server code. So, you know, you could write a Python library to interact with the same service that the GWT does, the GWT client does. However, and it's also very efficient for the browser. So like JSON, you know, you can directly evaluate it in the browser if you want. It's kind of very targeted at JavaScript in terms of efficiency. The problem I ran into, because this is the first implementation I did, is that if, you know, one of the other guys who are working on our stuff, he changes one of the Java objects and adds an extra field, or he renames a field, what happens is that everything breaks. And often you don't know that it's going to be broken until you actually test it in web mode or you test it end-to-end, which is kind of bad. I'd prefer to know when I'm editing the code that, like, he refactored something. And also, it's less efficient for mobile. So, you know, if you want to conserve battery power on these devices and you want to decrease the latency, you want to stay off the radio as much as possible and download as few bytes as possible. And then once you've got the data in, you don't want to take that much time to parse it. So, like, for Android, you'd have to download sort of a very verbose JSON syntax, then convert all this, you know, all the numbers from ASCII into, like, actual doubles or floats or whatever. And it could be a bad experience for mobile users. So protocol buffers are an alternative, right? So like I said, they're used by all Google services. They're compact and fast. They have this feature of composability, which is not too important for what we're talking about. They're forward compatible. So what will happen is let's say someone has a protocol buffer, which is just like a data structure you can send back and forth, and it has 4 fields in it. Let's say like your first name, last name, you know, age, and gender. And somebody comes along and they add another field. Well, what happens is a client who is inspecting the other one that only had 4 fields, and now he gets one with a 5th field, can kind of conveniently ignore these extra fields. So it's kind of forward compatible. It's a very nice feature. However, it doesn't have any built-in polymorphism, so you can't, like, have subclasses. Like, you can't have an animal protocol buffer that has, like, a dog and cat and horse, like, subtypes, sub-message types. But you can fake it. However, I like to use GWT RPC, and the reason I like to use GWT GUID RPC is that there's no pain to using it. You write an interface, you implement the interface in a servlet, and then on the client you invoke GUID RPC, GUID.create on the interface, and it just works. And the performance is very reasonable. And another cool thing is actually, you can sort of step through an RPC call in your Java debugger and have the breakpoint run on the server. That's like a really cool. You can step from like client to server almost. That's pretty cool. The problem is it's very GWT specific. What about Android? I mean, if you wrote your servlet using GUID RPC, how can people who are using Android talk to your servlet now? Well, one of the things I've been experimenting with, and this is something that I always try to throw in something that's a little, off the beaten path, is using Android to talk to GUID RPC servlets. So we implement GUID RPC on the server, but then on the client we implement GUID RPC in the Android And the way you can do this is if you use dependency injection, you can inject an implementation of an RPC interface on Android. Like, let's say it's like customer service, and there's a method called get account representative or something, right? So it's an abstract interface. And what you can do in Juice is you can inject a implementation of this by intercepting method calls to it. Now, with Juice, basically they use this AOP library, AOP Alliance library for doing that, and unfortunately it doesn't run on Android because Android doesn't want you to dynamically modify bytecode. But what Android does support is the original sort of method interception technology that's built into the J2SE that not many people use, which is the Java-Lang reflect proxy. So what you can actually do is you could intercept calls to that interface using this object and dynamically implement a call to a method that has no underlying implementation. So your get account representative thing can be intercepted, and you can catch that attempt to invoke it, and then use what's called the serialization stream writer that comes in GWT to invoke an RPC method over the wire. So you'd use the serialization stream writer, encode your method invocation, and then use the HTTP client to just send that over as like a post to the server. So I've prototyped it. It's kind of cool, and if it can be made to work, then you could actually write one servlet that could serve mobile devices, could serve GUID, and maybe even server-to-server calls. So I'm going to digress a little bit and talk about user management. So when you develop an application these days, usually one of the first things you start out is making a user table in your database, because you got to have users. So you got to store username and password. You got to have a sign-up method. You've got to be able to authorize them, and so on. But if you don't want to go through all that hassle, what you can do is, if you deploy the App Engine, you can leverage the existing user service API that they have. In that case, anybody can log in with their existing Google credentials. The other thing is you could use a library called OpenID for Java, and you could take any OpenID credential from other providers, like Yahoo has OpenID, MySpace has OpenID, and so on. People could log into your service with their MySpace credentials or with their Yahoo credentials, in which case you don't have to spend as much time implementing the authentication piece of it. But more than that, it kind of lowers the barrier to entry to your app, because now the user doesn't have to go through a really boring sign-up process, or let me think up another password. Let me fill out all my information. They just can sign in with their existing credentials. So that's one of the APIs that sort of helps your productivity. The other key piece when you're developing applications is, how are you going to persist your data? And the traditional way you do it, of course, with a LAMP stack is you have MySQL, and you use Hibernate, or use Rails, or use Django. Use one of those things basically to take your objects and map them onto the database. But Google provides an alternative to that. So App Engine, as you've probably heard, is not a relational database. This is what Google uses on their backend. It's a totally different data store technology. However, they provide an object relational layer based on the JDO standard. Now, you may not have heard of JDO until Google started using it. You probably were using JPA. JDO kind of died for a while. and JPA and Hibernate kind of owned it. But JDO actually has some features that those don't. It actually is more abstract than JPA. JPA is tightly bound to the idea of a relational database. JDO is actually so abstract that it can store data to almost anything. So if you write your application using JDO, you can move it from MySQL to App Engine and back. But more, if you go look at the underlying data nucleus libraries that Google is using, you could persist data into Excel. You can persist data into XML. You can persist data into almost any storage format. So, I mean, someone could hand you an Excel file, and you can basically do a JDO query across that. So it's really, really flexible. And the interesting question to me is what of the native storage in HTML5 or Android? Maybe a cool idea for maybe one of you guys to explore is perhaps a JDO mapping in GWT for mapping onto the native storage mechanism in the browser that's been made available these days. But the key takeaway here is that the JDO APIs that Google sort of settled on are very, very flexible, and you can write an app that does not lock you in App Engine in any way. So if you're sort of thinking vendor lock-in, I'll be stuck on Google. If you use JDO, you actually won't. It's kind of cool. Okay, so the next thing that Google provides, which is really powerful, is gadgets. So a lot of times, it might not even be necessary for you to develop an application where you have to, develop an entire website. It's possible for you to develop an application that lives entirely within the gadget. And there have been some success stories of people deploying gadgets on like Google I/O where they've made quite a bit of money from it. But one of the cool things is that if you develop a gadget, it can be embedded anywhere. You've seen it embedded in Google Wave today at the keynote. It fits in open social containers, Google Friend Connect sites, in Maps, Calendar, Spreadsheets. In fact, there was just announced yesterday the real-time gadget API where you can drop gadgets into the Google Chat window and implement real-time games. So if someone updates a JavaScript object, the other people you're chatting with, they instantly get a notification, just like in Google Wave. You just get the notification immediately. So what I'm going to show you is, and hopefully it's going to work, I'm going to show you how I was able to leverage Google Gadgets to solve a very real problem I had. So I had the problem of so how do I get data into my system? I could write like a really complex web-based UI that was sort of like a spreadsheet and allowed you to sort of import a CSV and some other stuff, and then choose what columns I want and how I want to basically graph it. But instead what I did, because that seemed very daunting, is I leveraged the feature of Google Spreadsheets, which allows you to drop Google GViz gadgets into it. So here's a spreadsheet I've got, and it's got 3 time series in it: price, oil, and food. And in between, you can see that there's these columns called markers. So what's going to happen is anywhere that there's a column called markers and it has text in it, it's going to drop like a Gmaps type push pin on that data point in the chart. So the cool thing is like if I want to chart all 3 of these, I can just drag select, just drag select that, and hopefully this will work. The network connection is not going to fight me. And let me just add a little extra flag there in case something goes wrong. Okay, so let me click Apply and Close. And there we go. So basically what you can do is you can write gadgets that live inside Google Apps. And what this gives me is the capability to say to people who want to put data into my system, go take your Excel data or your Google Spreadsheet data and drop this gadget in there. Export your Excel data into Google Spreadsheets and drop this gadget in there. And then you can share it with people and publish it to the web. So for example, this same gadget you saw right there, it can appear on any website. So here it is embedded on another website. Let's wait for it to load. Oh, there we go. So here that same gadget is appearing here. So you don't necessarily have to have the gadget live in the spreadsheet. You can drop the gadget in a spreadsheet, and then you can go put it in your own application, like I did, like you would see here. And the cool thing is if someone updates the data in the spreadsheet, it will be reflected here. So that is how you can make Google Gadgets work for you and solve a pressing API issue, like if you don't want to build your own spreadsheet. So this is leveraging an API called the Google Visualization API, GViz. I don't know if you guys went to any of the sessions, but it's kind of a cool API. You can pump data into it using JavaScript or GWT, and out pops any of, let's say, 15 or 20 different charts, pie charts, bar charts, scatter charts, animated charts, and things like that. And a lot of the Google products you see, like analytics and all these things, they kind of leverage this stuff. The cool thing is that third parties can submit new extensions. So let's say you guys come up with a new way to visualize data. Maybe it's a spider graph or one of these really bizarre or very artsy-looking graphs, hyperbolic charts and things like that. You can write it up. And it could be a JavaScript library, it could be a Git library. And you submit it to Google. And what will happen is it will appear, if you submit it to them and they approve it, in the spreadsheet. So when you go here and you say insert, and you pull up the gadget, it actually will appear here. So there's like a list of all the charts you can see here. So it's one way to sort of publish gadgets. And as you can see, there are commercial gadgets in here. Like Fusion Charts is actually a commercial product. So like this can be used to actually drive revenue. So if you've got a charting product and people start using it here, maybe they'll buy or license your real chart product. All right, so multimedia. So let's say you want to basically write something like TwitPic or one of these other photo sharing services, or you want to do like a video hosting service. But rather than build your own scalable, massive picture and video hosting backend, you can actually leverage Google's infrastructure using either the Picasa GData API or the YouTube API. And what you can do with these APIs is not only can you get a list of like photos that you've published to Google, you can actually upload multimedia over the API. So you can take photos or take videos and you can push them into Google's infrastructure. And then later on you can pull them out. And it's possible to develop an API, a website, that looks completely different than Picasa or YouTube. You can just set it on top of their APIs and sort of make a clone website that looks different, maybe better. In particular, I use the YouTube Chromeless Player API, and this is kind of an interesting thing. Let's say you don't like the way the YouTube player looks. You could write an application that pushes video into YouTube and hosts it there using the GData API. And then you can pull down their Chromeless Player API, which is the Flash player, but without any of the cruft around it. And then you could put on your own UI on top of that. So you might want to have different buttons for adding annotations, sharing with friends. You might want to totally redesign the way it looks. And it's possible to do that. Obviously, with HTML5 video tag, it would be even easier. But today, you can do it with the YouTube Chromeless Player API. Think of it as a way to sort of emulate the video tag today using Google's infrastructure. OK, so one of the last things I wanted to talk about is Google Checkout. So we came to, after we did all this stuff with the chart, we tried to do an OEM licensing model. So like people said, hey, we want to license the chart, and we want to basically use it in our application. But a number of people came to us and said, we don't want to license it. We just want you to host it. It's too much effort for us to do our own builds, build our own GUID apps and stuff like that. We just want to, you host the data, you host the chart. We just want to pay a monthly fee. So approximately, not even 2 months ago, when Google App Engine launched, we started doing a software as a service implementation. And we came to the problem of well, how do we take orders? How do we take monthly orders? And Google recently launched, if you're not aware of it, what's called the Subscription API. So you might have like an online newsletter, or you're selling some other kind of digital good that you want people to subscribe to and pay a monthly fee. Maybe it's an online multiplayer game or something. There's a new API where you can charge somebody a reoccurring monthly fee. So we looked at this and we said, oh wow, this fits, Google Checkout fits exactly what we want to do. We can use this to monetize our software as a service. However, how do we integrate with it, right? There's a number of different ways to integrate with it, and we sort of needed a lower level control of how the order processing works. And Google lets you have as much or as little control as you want. So you could tell Google, handle all aspects of the checkout process. Like, all I ever want to see from you at the very end is an email that says you charged the person's credit card and ship the order to them. So they can handle the entire workflow. Or you can actually intercept that process at any point in time with several APIs, like the Merchant Calc API, the Notification API, the Order Processing API, and react to the different stages of the order process. So we actually integrated with the Notification API. We wanted to be notified after the person submitted the shopping cart so that we could do additional things, like send you an API key for using our widgets and things like that. So this is what like a checkout flow looks like, and there's various parts where you can integrate into it. We integrate only at the level of a notification API. That's sort of the second. That's like sort of the second divider over. But so the question is, how do you do it? There's many different ways to do it. We chose to use the XML API to the export. And since we were on App Engine, we had to figure out how do we do this quickly, because we were trying to do it in 2 months before I.O. We were trying to ready this whole thing so that we could show it off at I.O. And there's this API that comes with Java called JaxB. I don't know how many people are familiar with it, but it basically allows you to map, just like JDO can map database data into object relational mapping into Java objects, JaxB can map XML into Java POJOs. So what we did is we took Java beans, basically, Java POJOs, plain old Java objects. So you could say, I want this tag to go into this field, and this tag to go into this field, and this attribute to go in that field, and so on. And it's bidirectional, so you can take Java objects and turn them back into XML. The cool thing is that you start with a schema. So Google publishes an XML schema for all of their checkout-related APIs. You can pump that into the JaxB schema compiler. And what it does is it looks at the schema, and it generates Java objects for every XML element that's important in the schema. And then once you got that, you're pretty much done. You can take XML from any source, like let's say from Google notifying you an XML message from someone checking out, and you deserialize it into a Java object and just call getters and setters. And this diagram represents like what we're doing. So we basically take notifications back from Google at the bottom, and we deserialize them in a servlet into Java POJOs. We do our business logic, interact with the App Engine data store, and we send requests back to the checkout API. However, if you were to take what I've just told you and you go ahead and try it, you're going to kind of be for a rude awakening, because unfortunately, JaxB isn't a whitelisted API on the App Engine. So App Engine has this notion of what's allowed, what APIs are allowed, and which aren't. JaxB is actually part of Java 6. It's part of the package javax.xml.bind. But App Engine won't let you use it. So there's a tricky workaround. And one of the things you can do is you can use these utilities like jar, or you can use IDE refactoring. And all you got to do is move into another package. So you can move like javax.whatever into appengine.javax. And once you do that, it works. So if you guys, anybody in the audience is doing JaxB integration in App Engine, because this is a highly starred issue in the issue tracker. It's got like 70 votes on it. If you're interested in doing it, I have a build of the JaxB libraries that will work in App Engine. So you can send me an email. So to recap, there's 60-plus APIs documented on code.google.com. There's a lot more of them, like Juice in code.google.com/p. There's lots of soft-launched APIs in Google Labs. And there are related APIs that are totally hosted on separate websites. Like Apache Shindig is not really a Google API, but actually it is the reference implementation of OpenSocial. So if you want to build your own OpenSocial container, make your own social network, you just go download Shindig and you're done. Chromium, the browser, and then various OpenSocial Foundation and Open Web groups actually have their own sort of like libraries, and a lot of the people who are in those groups are Googlers who are contributing code. So sort of a lot of stealth Google products out there that you may not know about. So just to summarize, there's an API for almost everything you want to do as part of your normal application needs provided by Google. But by no means am I saying like only use Google services. You might tie yourself to Google so tightly you might find yourself wishing that you can get away from them later. But when you're developing an app, it does allow rapid prototyping. You need to do, if you want to do video hosting and picture hosting, stuff like that, there's a back-end infrastructure that's very scalable you can just leverage off the bat. I call it one-stop shopping. So whenever I'm developing an app and I need to do something and I don't feel like implementing myself, I go to Google and see if they've already got something for me. So that's basically it. I hope people got a good taste of the big variety of APIs that you can sort of leverage with Google, and I'm willing to take any questions.